right, let's see how Newton's second law relates to my workout today. All right, 2.5 pounds. No problem. 2.5 pounds, super heavy. 10 pounds. Whoa, it's taking more effort and force to lift it up over my head. And my acceleration has slowed down. All right, 25 pounds. And don't do this barefoot, guys. I'm being really stupid. Here we go. More effort. I did it. My acceleration has slowed down because my effort has to increase the force to pick them up. So obviously, the less mass, the easier it is for me to lift something. The more mass, the harder it is. Most of you guys did a great job with your answers from yesterday. That's just a little example of Newton's second law of motion. We're going to go through a couple of examples today of how to figure out Newton's second law with our formula, mass times acceleration equals force, and then I have a demonstration to show you with arm wrestling certain people in my family. All right, let's review from yesterday. Newton's second law says that force is equal to an object's mass and the acceleration of the object, meaning I have to increase the force related to the mass of an object or the acceleration of an object. And there were 3 principles that we talked about yesterday. The first one is the greater the mass of an object, the greater the force needed to move it. So with my my little weights back there, the greater the mass, the greater the force needed to pick it up. I needed to increase my force in order to pick up the 25-pound weight. The 2.5-pound weight, not a problem. Thank goodness. If it was a problem, there's a problem with me. All right, so that's our first principle. The greater the mass, the greater the force needed to move it. And I gave you 2 examples of like moving an empty cardboard box versus a box filled with a person, or trying to hit a golf ball versus hitting a bowling ball with a golf club. You will have problems if you hit the bowling ball with the golf club. Second principle, the greater the force exerted or used on an object, the greater its acceleration will be. So the greater the force, the harder I swing the bat, the greater the acceleration that ball, once it is hit, it will send that ball flying a lot faster than if I was just to do a really rinky-dink kind of swing. Third principle, the greater the acceleration, the greater the force put on an object. So if I throw a fast pitch, I am moving my arm as quick as possible, whereas if I'm throwing a slow pitch, it's still moving fast, but definitely not as fast as a fastball pitch, okay? And I gave you 2 questions yesterday. Most of you guys have turned it in. Most of you have done a really good job answering this question. Some of you, we had to go back and look at what principle this supports. And the question was, why does it take more force to pick up a full water jug than it takes to pick up an empty one? Most of you said the correct answer, that the full jug has a greater mass. The bigger the mass, the more force needed. So what principle did that support? Was it the first principle, the second principle, or the third principle? That's right, it was the first principle, which is the greater the mass of the object, the greater the force needed to move it. So let's look at a couple of examples and let's see how you are with your math. Some of you are like, oh boy. Don't worry, this isn't that hard. So we have our formula right here that we know that mass times acceleration equals force. So in order to find out the force of an object, I need to multiply the mass and I need to multiply the acceleration. Now remember, mass is what is in an object, what is an object is made up of, and you're usually going to find that in units of weight, like kilograms. And you can see that we have 10 kilograms here, 10 kilograms here. This one's a little bit different. We'll talk about that in a second. And our acceleration is going to be some sort of speed, like kilometers per hour. Okay, so if I multiply them, I should get my force. So the first question, if the mass of an object is 10 kilograms and the acceleration is 10 kilometers per hour, how many units of force were applied? Well, for all my mathematicians, 10 times 10 is what? That's right, 100. F is force equals 100, because we take 10, which is our mass, and 10, which is our acceleration, and we multiply the two numbers. 10 times 10 equals 100. Second question, if there are 20 units of force, now we have our force already. We have 20 units of force and the object weighs 10 kilograms. We have our mass and we have our force. What is the acceleration? Well, this is simply going to take our mass and our force, and we're going to divide, because if we multiply on this side of the equal sign, if we're using something from the other side, we have to divide. So what do you think? We're going to take 20 divided by 10. What's our answer? That's right. Our acceleration is 2 kilometers per hour. We can reverse check that. We can see that our mass is 10. Our acceleration is 2. Well, 10 times 2 equals what? That's right, 20 units of force. Man, aren't you guys glad we get to do math and science? No? No one? No one? Okay. Well, we're going to keep going. Next question. If the acceleration of an object is 10 kilometers per hour, so we have our acceleration now, and there's 5 units of force. Okay, so we have our acceleration and our force. We're not going to multiply them. What are we going to do instead, because they're on opposite sides of the equal sign? That's right, we're going to divide. I want to find out what the mass of the object is. So what do you think that's going to be? Here it comes. Our mass equals 0.5 kilograms, because I took my units of force and I divided it by 10. That gives me half a kilogram. I hope this makes sense for all of you. You are simply just multiplying or dividing. On our quiz, you guys, which will be next week sometime, you guys will be having to do some calculations. Don't worry, I'll have the formulas there. Whether you need to find mass or acceleration or force, I will have the formulas there. And yes, please use a calculator, even though a lot of this math is easy and you should be able to get it. But as I say in science, no shame in using a calculator, because it is science, not math class. All right. This brings me to the next thing that I want to do. We are going to look at an arm wrestling competition between me and various people in my family. And you're going to see, observe, and discuss how force, mass, and acceleration affect the results of the arm wrestling competition. You'll notice that under this video, there is a document that you can download, and you will need to use that when observing this video and the arm wrestling competition. Once you print off or make a copy or write down on a piece of paper the questions, there's going to be 4 observations that you're going to make. You're going to watch the next video that's under the PDF of the arm wrestling competition, and you're going to write in complete sentences how the mass and how force and maybe how acceleration affected the outcome of the arm wrestling competitions. There's 4 observations that you're going to need to make. Again, you can either print off the PDF, take a picture, send it to me. You could just write it on a piece of paper, what your observations are, or type it out in an email and send it to me. That's going to be your daily grade for today. All right, so again, print off the PDF or make copies of it or write it down, and then watch the next video under it of the arm wrestling competition.